This is a video to review basically working with a discrete random variable. So let's say X is the number of breakdowns in a week that a machine does inside a factory or something. And let's say if it never breaks down that week, then X is 0, and that happens 15% of the time. Breaking down once happens 20% of the time. Breaking down twice happens 35% of the time. And breaking down 3 times happens 30% of the time, which sounds like a sad factory situation. Okay, so this is our discrete random variable probability distribution function, because it tells us each outcome that X can take on, and it can only take on these whole numbers of 0, 1, 2, or 3. So that's why it's discrete, and it's accompanied by the corresponding probabilities. So expected value of X comes from adding up each of the outcomes of the random variable multiplied by their probabilities. So what this is going to tell us is basically if these weeks are repeating over and over and over and over, what would be the expected number of times that the machine is breaking down per week. So each of the outcomes are weighted by their probabilities. So I'm going to make a column here which makes it easy, that I multiply each of these X's times their corresponding probabilities, and then this gets added. So when I add those together, I'm going to get, it's 1.8. So this is telling us 1.8 breakdowns per week on average. So even though it's either breaking down or it's not, the X outcome is in whole numbers, thinking about this statistical experiment repeated over and over and over, we're averaging 1.8 breakdowns per week. So that statistical average is the meaning of our expected value of X.